Hey, morning, guys.
Hey, morning, everyone. Sorry I got late. So, Luis is joining, so give exactly 1 minute and we can get started.
Hey, Srinivas, if you're late, text us before we'll sleep for extra time.
Okay, sure.
Morning, God.
Hey, Luis. Luis, let's get started. It's 8:05.
Yeah, let me just pull this up here. Okay. So, okay. Well, good morning, everyone. Looks like we're a little slow start today, but hopefully we're back in the groove. Hopefully, everyone took the coffee this morning. We're going to be talking about numbers as we did last week. So it's more, again, understanding how to really cost out our Gen AI initiatives. I know we missed a week, so I'm going to go just repass what we talked about slowly, probably show a little bit more examples for you to capture the principles and continue off where we left off from that following week. All right, so last week, I think 2 weeks ago, we talked about the importance of having good data quality, how we should do experiments, how there's a cost of development for each of these areas, and understanding what are tokens and LLMs. Now, we discussed that how it's priced out in a chatbot is how many tokens there is. So if there's one token, how much that one token would cost. And there's two types of cost. One, for when you write to a chatbot, and two, when you output information. So if you were to ask a single word and say hello, that could be one single token. And one single token input could be 0.0009 cents, and then output hello, how are you? Could be 0.0018, right? Because you can see that it's usually the output usually 2 to times 4 the price of the input. And I'll show you an example on our Google AI Studio where we can look at AI Studio and it shows you the cost of this. And remember, the cost they show you is through for 1 million tokens, right? So this is where we talk about how 1 million tokens is really cost effective. If you're running 1 million tokens, it's only about $2.50 for GPT-4. For Claude's a little bit more expensive. It's $3. 3.5, it's one of the older models, they're only charging 50 cents for it, right? Because depending on how smart the model is. So that's only for 1 million tokens. So if you divide that 1 million divided by the price point, you can see that it's less than pennies that you're paying per token. And really to get a really high really to get a high cost out of your chatbot, you need to be having people writing essays, over 100,000 token limits, etc., for that to be really expensive for you to be running. We also looked at comparing two different models. So if we were to look at having like simple conversation down here, the quick brown fox jumps over a lazy dog. See, this is an input example of the input model, which is about 50 tokens. I think this is what it was. So now we know that 50 tokens is about, sorry, this conversation is about 200 characters. So we multiply that by the day, right? So we assume 50 conversations per day. So let's say in your chatbot, you're going to have 50 people going in there and they're going to have a conversation with their chatbot. And in each conversation that happens uses about 200 characters or 280 characters for output. So that's sort of what we're going to be guiding our bases on, right? So this is what you have to do when you look at a chatbot. What's the average chat that someone is having with their chatbot? If someone's having 2, 3, 4 talking back conversations before they sign off, is it 15 back and forth? Is it 20? Right? And then you would have to do the average of that. So you can also estimate, right? Looking at previous inputs with maybe live agents and say, usually some people stay online for usually only 5 minutes maximum. They only type this much. Therefore, the average amount of characters they're using is this, right? And the average output that our agents were using is this. So you can use that sort of as your baseline of how much is your input, how much your output. But right now, for this example that we showed last week, we're assuming 50 conversations and an average about 200 characters. And again, example of 200 characters is below here. So it's not just a one sentence. It's 1, 2, 3, 4, 5 different sentences being asked, right? Now, if we use the same type of output from the LLM and we're getting that in, then we can see that obviously we're amounting more of that output, 14,000 characters, and then you can multiply that by 30 days, and you finally get the output. So you can see here that we're not using 1 million tokens on this one part. This 200 characters is less. It's less tokens than that. And also your outputs will be less tokens than that. So if we know that, going back to the first page, that's $2.50 for 1 million outputs, and we're only using less than that, then we're obviously not going to be using the full amount. And therefore, if we're using 50 conversations and we're using it times 30 days, we get to only $1.24 for the cost of having 50 daily conversations for that month. Then we compare that to Gemini, which is a cheaper model, you get 62 cents. All right, so we have questions. Nagesh, you had a question? Yeah.
Sorry, Luis, I had a related question.
Yep.
In ChatGPT, we can provide your preferences, which will be used for every query that you make. Would that cost too? That's one. And the second cost is, now recently there was a news that ChatGPT remembers all the conversations that you make. So would the historical questions also be supplied as part of every new query that we write?
Okay, that's a really good question. So one, what happens if you were to write context to a model, a system prompt? So what happens is every single time you add a system prompt to your model, it will send your prompt and the system prompt at the same time. So that would add to the input of the model. So the answer your first question, it does add to the input. Now,
Yes.
conversational history is completely different from what ChatGPT is doing. So usually in a chat conversation you're having with a chat, with like a chatbot, what happens is you send a message, you receive a response. But in order to continue context and understand what you're doing, it will then grab the top 2 conversations and part of your history and then add that to your chatbot. So you can ask and say, how can I order shoes? And the response is like, you can order shoes from this type of store, this type of store, this type of store. And then you respond, are there any other locations? So your chatbot won't know the context unless it's fed the history in the input. And this is what we talked about last time is that that's why you only see that these models can only take about certain amount of questions before they start slowing down. You'll see in Claude, they'll say, oh, you need to start a new conversation. You're about to hit your max limit. Or sometimes in GPT, when it first started out, it's saying you're starting to hit your first limit, blah, blah, blah. What's going on? Now, ChatGPT's history of memory, what they just created, is different. So what they've done on the back end is created summaries of all the different type of conversations and extracted main points, and then use that to the model, feeding it to it. So they're using a different type of technique. They're using different ways where just for a better user experience that they're doing on that way. But of course, they're not feeding every single thing you've written to the model. Again, that would be really expensive, and the certain models can't handle that. So they're looking at a back way of creating summaries, bullet points, and then use that to sort of create who this person is and how that happens. So going back to what we looked at Microsoft Copilot 2 weeks ago as well as the current architecture, we can say that you can ask a question to the chatbot can answer it because it only has a maximum outputs. But then you can have another LLM that can inject, oh, this user likes to have this type of response. And because of that, it can adjust your response based off that and then come before coming out to you, right? So it all doesn't have to be sent out in one response, one and go. You can have multiple tools checking the responses, modifying them as they go.
This is very insightful. Thank you, Louis. So does that mean, even though there is a cost optimization that ChatGPT has done, but your next query will always be more expensive than the previous query because of the continued increase in the length?
Correct. And I'll show you an example of that, right? And I'll show you how AI Studio, when we'll go in there, we'll type something in and then we'll continue conversation and you'll see again how the chatbot continues scaling from there.
Great, thank you.
Nagesh, you had a question?
Yeah. So basically, when you enter something in the prompt, right, there are two questions for me. One, when you enter something in the prompt and then they send it, then that's not exactly what the tokens come to, right? Isn't that correct? Because it can just tokenize whatever you have typed and then it goes to the LLM. Is that correct?
So your question is it just that, the input? So whatever you, so, whatever,
So for example, you said Apple, right? Apple as a, maybe it does something to Apple, or it is maybe a complex word. So does it break and then send, and does it count those as separate tokens? One word to multiple can happen, right? Or does the LLM, that's internal to enter a LLM and then they don't consider that?
Yeah, for sure. And this is something we definitely talk on Gemini 101. I'll quickly brief talk about it, but what we understand is that in how each model breaks down words into different tokens is not this, it's not the same across different models. So Meta has their own tokenization system. OpenAI has their own tokenization system. Claude has their own tokenization system. So how they count each word can be broken down in many different ways. So let's say as a whole paragraph could only be 30 tokens for OpenAI, but for Meta it could have been 38 tokens, or for Claude could be 36 tokens, because the way they count tokens is basically built on their transformer and how they are able to understand words. So there is no particular one way how to count tokens. You usually have to look up a token calculator based off your model, input your paragraph, and that will give you, if you write your paragraph in, it will usually tell you, hey, this is how many tokens it is. But you can sort of guesstimate by saying the average 4 characters is usually 1 token. Usually thinking about that way, and then that could sort of be, okay, understanding, example, understanding is a big word. We can count the first one probably 1 token and standing as a second token. So that's 2 tokens. Meanwhile, hello could be 1 token, and this very long word could be broken down into maybe 3 or 4 different tokens because it's a longer word. But there is no particular one way, simply because there's different models that use different ways how to calculate what tokens are. But you can definitely use token calculators to help you understand and break down what you think your tokens will be.
Yeah, so but there's no guarantee that it will translate to the same thing, right? Because let's say you show it in the, use it in the application, and then it just kind of like breaks it into multiple tokens. So that's happening behind the scene before it actually gets calculated for the cost. So I mean, I guess we can just go with the average, which you mentioned, like, you know, like the 4 characters per token, and then just kind of go off of it, right? Is that correct?
Yeah, so if you know you have an average of like 50 people write in matches of 50 characters or 100 characters, and that's the average, then you would probably estimate that average across everyone, right? Because there might be some people that write less, and there might be some people who write more, right? So you definitely want that mean average cost. And if it's less then you budgeted properly. But if it's more than, you didn't budget properly, or people are abusing the system. So this is why you have to be very careful of always watching the cost and ensuring that the proper things are happening.
Yeah, so I mean, I'm not sure whether I was super clear or not, but for example, anti-establishment, whatever that is, and then it breaks it into multiple tokens, right? So if it is multiple tokens, does it mean that ultimately when it gets calculated, it's using the multiple tokens length for the cost, or is it using the amount of characters in that anti-disestablishment material? Yeah.
It's only using the tokens, right? Because what happens is LLM models don't read words. They don't, whatever you write you're writing your words, they don't read that. What they read is the conversion of your words into tokens. And tokens are vector storage, are vector row numbers. So when you're ingesting, we're writing something to the token, to your LLM, it won't see the word anti-establishmentarianism. It's going to only see 103567 comma space vector 46. It's only see the token vectorization of your LLM coming in. So when it calculates the cost, it's going to calculate the cost of tokens coming in, not the amount of characters. It's counting, okay, I receive 4 vectors coming in, that gets counted as 4 tokens. So that's how it works.
So, and if you are using RAG, right? So is there a way you can control the number of, I believe you can say the first 4 results from the RAG, you use it for the thing, right? Because that becomes a little bit of a black box. All you're saying is use this RAG, right? A vector store, and then you use the LLM and it choose me the best answer out of it, right? So in that case, and also, is there a tool to, how do you do it? Like maybe an example would be super helpful to find out what RAG is actually, how do we see that this is what the RAG is sending as an amount of characters? Because that's super important for calculation in production, right? If you're using RAG.
For sure, and this we'll probably touch on 103 because it's more of a business course, this one. But usually what you could do in RAGs is you set the amount of characters or tokens per chunk, right? And this is how you control your cost. You can control how big and how small your chunks are. So if you know you only want to have very low cost, then you can break out your chunks into smaller chunks. And then when you pull out which ones are most relevant, it will pull out the smaller chunks and therefore be less cost effective, right? So this is how you sort of optimizing that, because you can say, okay, I know it's going to pull me the top 3 chunks. I created each chunk to only have 30 tokens. So it'll be 30, 60, 90 tokens plus whatever the input of the user is coming in. That's going to be the input cost always of my model.
So you can say how many chunks should be used as a part of the input to the LLM?
You can choose 1, 2, 3, 5, 10, 20, 30. You can set it, right? When you're creating RAGs, you're pretty much building it in Python. And you're building these environments out, you dictate how much similarity score embeddings you want. You can say top 1, top 2, top 3, top 4, top 5, and you can control the cost that way.
Okay. So like the top 10 results is what you can say, and the chunk size. So the combination will tell you what is the
correct, and then you multiply that by how much tokens are in each chunk that you have built out.
Okay.
So that's a good question. So before jumping to that one, is that stored on client or server? Seth, are you talking about the memory or?
No, the thing is, right, in a conversational chat, generally, like you get into a session, like, say, for example, there is a scoped session, right? I mean, this was a tag along with what Srinath was asking, right? Oh, does it store the previous, like how is GPT-4 optimizing the cost kind of thing, right? So, like, say, for example, a user who is using the GPT as an vagabond, right? Like, I don't have login credentials, nothing, right? I'm just using it on a random login, ask question, and get out, right? At that point in time, it was more around the user sessions and paid version, non-paid version, those kind of things. That's the reason I was asking: is it stored in the client or in the session or in the server side? Right?
Yeah, for sure. So when you don't sign into those things, there's no way that OpenAI can attribute to you, right? So it has to be per session, right? When you go in there, ask questions, per session gets stored. But once you have a login and they store it, then that's being stored on your client server.
Historical,
because they need to pull if you want to see past history conversation we did a week ago, that needs to be stored somewhere.
Sure. Actually, there could always be the smart clients, like we store some session data, though you're not a logged in credential, right? Logged in user. That's fine. I understand now. Thank
Yeah,
you.
and what they do is sometimes they store those conversations to use for training as well, right? So that's why they do,
Right, sure.
because yeah, they
So
usually use.
if you're, let's say you have a session between the application and the server, chat server, sorry, OpenAI, right? But then you are trying to get the Gen AI response for multiple users, but the server is one. So are you going to create a chat session for each request? You see what I'm saying? Like, because now the context is no more common between the users who are hitting whose requests are going to the server. So how would
Yeah, that's a very good question. Because you guys are looking at how you're running this in production. So you need to look at concurrency, right? How well your model can handle 30, 40, 50, 60, 100 requests coming in at the same time to an LLM, how well it's going to respond to that, how it's going to handle multiple requests coming in, how it's going to handle multiple conversation histories, right? We definitely talk about that in a few slides right now. So I just said hold off to that question because we're going to talk about even latency and how that affects, right? Because if you're having 100 people trying to chat with the model and answering the same question, obviously there's going to be some sort of latency. There's going to be some sort of history. There has to be some sort of infrastructure. So how do LLMs support that today? So that's something we'll talk about in a couple of slides. So we could just hold off a little bit. And we'll definitely jump there. And then I'll go to Shobha's question. What is the downside of increasing or decreasing chunks? So that's correct. So there are sometimes you might lose context, right? So if you have smaller chunks, let's say you have a scientific paper that goes introduction, body, body, body. If you have smaller chunks, and it's about scientific papers, you might miss out what happened in the first paragraph of that second one. So you're not getting that full context of what's happening. So Jason did a good she did a good response of answering why sometimes it's when you do RAGs, it's a science in the sense that you have to increase chunks, decrease chunks, check which one's giving better responses, which one's getting lower. You have to evaluate how your model is responding, right? And this is the whole part of the evaluation is you simply just say, okay, I'm just going to check my model, go in and go, and that's it. Because there's accuracy, you have to think about, there's cost effectiveness, you have to think about, there's multiple ways to make it more efficient that way. We'll talk about that.
Luis, this was a leading question sort of like, so there is always this, what I meant to say is there is downside to meaning impact to the quality of the response, right? Because if it's only first few tokens, then there's a lot of context is missed.
So what's the
there
downside?
are trade-offs with the costs. Yeah. So are there any other ways than playing with the chunks?
Yeah, so another downside of increasing your chunk size is your context window, right? So let's say you have an LLM that has a very small context window and you have very large chunks. We know that models can only take about a certain amount of context. So if you're setting in multiple large chunks to the LLM, and so you're saying the top 10, this could max out your input of how much it can use. Maybe it'll cut off a chunk that you don't have. And sometimes it might respond with things that aren't, maybe because there's too much information now, may not produce the right information. Like the whole point of RAG, we're trying to say, like the reason why it was created is that LLMs can't read 50 scientific papers at the same time because they can't handle all that context. And plus the cost of that is astronomical. The point of RAG is to only find the sections of your data or your paper that are relevant and try to feed that to the model so it can better answer properly in a most cost-effective way. So that's the whole point of RAG. So again, knowing that that's the goal of RAG is to filter out the most important sections. Then that comes down to now, okay, well, what chunks are more expensive? What are better parts, right? Because then that comes back to your chunking strategy. Is it better to chunk based off paragraphs? Is it better based off sentences? Is it better to chunk off 2 lines? Again, it depends on what are you parsing. If you're parsing logs, are you parsing books? It's a lot of variables when you think about when you want to build a RAG that's simply just not a one-page template and just go. You need to really think about what's your data, how you're going to feed that to your model and understand that from there.
Yeah. So, what are the knobs here? Just is it for the cost? Is it fair to say just you play always with the tokenization? That's the way to control the cost, whether it's higher or lower.
Yeah, to control the cost, you really need to understand in a RAG situation of how much chunks are going in. And let's say you know your chunk size. Let's say you use it per paragraph, and each paragraph is, let's say, 50, 40 tokens. So you know you're going to be sending 3 chunks to your model. Then you have to multiply 30, 60, 90 tokens plus whatever the input is. So let's say the average, some people put in the average token is 50 tokens. So you do the 90 plus the 50, and that'll always be your input. And that's how you sort of calculate the cost. If I'm going to do a RAG and it's going to show these top things, then I know it's going to be about 140 tokens every single time for an input. Like that's the average cost. My output, then I'll that afterwards. But now that you know what your average input is, because you know how much and your chunks are sizes, then that's how you can get a really good calculation. Now, I haven't talked about chat history in here yet, but again, now that you have that responses, and say your output is 130 tokens, you don't have to go and multiply the chunks in that second investigation, because now what you're trying to do is the input and output only, right? So if your question is, how does this work? It came out with 60 tokens. You only grab the input and output. You don't have to worry about calculating what happened inside, because you're only interested in feeding that chat history, not the chat process, to your model. So then you would grab that top chat conversation, add that to your bottom part, and continue from there. Okay, so I think there's a question here. For the word understanding, there are 2 tokens in your example. What about embeddings? Is it 1 embedding or 2? If it's 2, then doesn't the context get lost? All right, so these are very technical questions. So in order to understand a little bit more about embeddings and context and everything like that, you have to understand that there's something called embedding models. Embedding models have been pre-trained on English words or whatever language you're using, and which captures definitions, rules, and everything based off every single word that you could think of in the example, the English language now. So when you break out the word understanding, you'll think of it as a captured in a JSON format. So understanding 2 tokens, 2 vector stores, but they're captured under one umbrella, right? So understanding, so what you do in embeddings, it looks at the word before, it looks at the chunk before it and the chunk afterwards, and defines the rules of which one requires more attention, which one understands there. So the context doesn't get lost simply because the embedding models have been trained to sort of look around attention pieces looking at that as well. Okay, there's a follow-up question. Do we have control in deciding I want understanding as one token, or can we maintain some dictionary words which we consider as one token, say special character suppose a token? All right, so again, you can't really decide what it depends on what's considered a token for each LLM model. It could be that, like I said before, OpenAI considers a certain word to be a token, but in Meta's and Llama models, they consider that 2 tokens. And so example, like special characters can be defined as a token in one model, meanwhile special characters in another model might not consider that to be one token, maybe it's combined with something else, right? So again, there isn't one rule. I can't say, hey, this is how exactly it's going to work. You sort of have to use these token calculators. So just go on Google, just put OpenAI token calculator, Llama token calculator, Claude token calculator, put it in the paragraphs that you're looking for, and that will give you more of a realistic view of how much tokens could be used. Yeah, so I think that answers question Satya. If there's formatting, if there's commas, if there's like I said before, like simple here, like quotations, all that will add to the model. So there's actually an interesting paper that says every single time that someone writes thank you to an LLM model, although it's not necessary, is costing millions and millions of dollars every year, because their output's not necessary. Simply just because you're writing thank you causes compute, causes transformers, causes all that. And although you think you're doing good because you're doing that conversation, but in the end, there is diminishing cost return of this writing thank you to the model, because in the end, the model needs to consume everything that happens in the chat history and say thank you in that case. So yes, sometimes it's better to be thankless if you're being cost effective, if you want to be climate and global warming effectiveness. So yes. All right, great conversations. I need to sort of keep going because we're still reviewing last week's information. But we talked about RAGs last week as well. So in order to have a RAG, you need to have a vector database. You need to have an API where you're calling in the LLM. We talked about re-rankers. I won't go into that one, but again, this is optional. If you want to re-rank your embed into your chunks to see which one's actually better, you need to host where the model's going and the monitoring cost, right? So again, this is just a quick estimate. I put this in here because you might use this in your own proposals of how you're going to be suggesting a RAG. I put different types of databases, different types of LLMs, the cost of running something 300 queries a day. Again, this is not including chat history. This is simply just someone asking questions, someone asking questions, someone's asking questions. And simply just have your own component of, okay, if I were to build a RAG that has very small embeddings, again, we're only looking at 10,000 vectors. So how you would do this is, again, go use the calculator. If you have 30 pages of data, how many vectors would that be? It would be very small, maybe 100, 200. Let's say you have 300 now, then you're looking at 10,000 vectors. But if you have over, let's say, if you have 500 million documents, right? What's that cost? And go from there, then it would definitely go into that, right? So definitely it's about RAG is very good. And again, it's all about how much data you have and where you're going to store it. So yeah, if you have over 1 trillion documents you want to try to do RAG on, I definitely would say try to go to professionals, and then that's going to cost you a lot of money if you try to do 1 trillion documents, because you get charged of how much document is being stored, right? Particularly like on your enterprise data, on your enterprise servers. If you have 1 trillion data, where are you going to store that? Who's going to store that? What's that storage cost? And usually vector databases are more expensive than your typical database centers, right? So you need to be thinking about what's the real ROI in this case, and go from there. Okay, so Nagesh, you have a very good question. I will have to pause that to the end. We're just trying to get through the part here, but we can definitely talk about that after class or on Wednesday about open search for RAG. Okay, optimizing RAG. So there's different ways you can optimize the cost, and I think this is someone talked about last time before was doing caching, right? Semantic caching is something that's very that people are using today. So example, you ask a question, how does this work? And then your colleague asks the same question. You can sort of have a storage bank of cache, and then you can have that same answer queried without hitting your queries, without looking at your top parts and seeing that question's already responded, and you can pull out, right? So you can use that to help optimize your cost in doing that as well. And also batching, you can sort of do batch to your RAGs. Let's say if there's 10 people asking questions, instead of sending 10 requests to your model, going from there, you can sort of batch your questions, ask them and respond back. And again, if speed isn't the issue and there are people who just want to know questions and they're willing to wait 10, 15 seconds or a minute, example, to get the responses, you can use then batching to sort of optimize and really get the most money out of your back and forth, right? We talked about chunk optimization, find the optimal chunk size. Again, if it's better to have larger chunks, smaller chunks, again, what's bringing you the best results and what's the cost of it, right? Let's say having larger chunks works better for you because it's providing more context to your model, but always remember that's going to come at a cost because you're feeding more inputs to your LLM. Filtering. So instead of, let's say grabbing 10, just say you want the top 5 results to your LLM from your RAG, but let's say each one's divided. Let's say you have different rules for simple credit cards. There's Visa, Visa Gold, Visa Gold Plus, etc. Sometimes RAG might have an issue finding what is the right chunks because it's using the same word Visa Gold, and just because it has the Visa Gold Plus won't eliminate a chunk from that search. So what you could do is you can have metadata filterings and say these are the credit cards, these are the chunks only for Visa Gold. These are the chunks for Visa Gold Plus. These are the chunks for Visa Gold Classic. And because you put that filter first, you can have your RAG first filter out for that product first. And that way you know that only your chunks that are optimized or only the chunks that are made for that product will be taken out. And this is, people try to solve this to many ways. The most simple one I always put is filtering by simply just adding metadata to your chunks, dates, sections, products, etc. Can also help and improve your RAG's extraction. Hybrid search. So how to filter and know the text is referring to a product. So again, you use metadata, you do metadata tags, right? So you know that this section of Visa Gold Classic is only for Visa Gold Classic. Then when you embed and you chunk it, you add metadata tags to it as a separate column, and you can put in there what are the products. And so when you create a prompt to your RAG and say, please respond this, and also then you would say, then use metadata to first filter out before handing out the chunks. So then you customize your RAG to use metadata filter first before then retrieving your chunks. Hybrid search. So like I said before, when you're asking a question, and it's going to pull information from your vector store database to extract chunks for you. How does it do it? It's not using LLMs to extract the chunks from you. It's using NLP techniques. It's using, again, could be cosine similarity scores, could be approximate near neighbors. There's different ways, or keyword search, right? Here's these keywords, those are keywords. Here's a top score for each chunk that has the highest keywords. There's different ways how to pull information from the vector store database. Hybrid search is a combination of two. So you could be using cosine similarity score and keyword searching to make it to combine for a final score. Rather than just focusing on one technique of extracting chunks from your data, you can do different ones. And the only way you would know that hybrid search works for you is, again, having a RAG evaluation spreadsheet. How accurate is it? Is it pulling the proper information? Is it ground, et cetera, et cetera? If I add hybrid search, does it improve my accuracy? Does it lower my accuracy? So again, you won't know how well each of these different ways of doing this, but unless you go in and have an evaluation sheet of how well each model and each function is doing. So one thing to note, that vector database can scale with data size and scaling linearly, and there's different retrieval strategies, right? And again, this is something we cover on 101, but there's different vector storages that have different retrieval techniques that you can use. For example, BM25 is an elastic search that you can do on your vector scores, but you can't do BM25 elastic search on, let's say, ChromaDB, on a ChromaDB vector database, because it's not made to have it. So each vector store and where you're storing the data will have its pluses and pros and cons of what are extra things it can do to retrieve and reduce computational cost. So when you look at choosing, when you're doing a RAG, always look at where you're storing your data, and there's actually pros and cons of using different types. You can self-host your RAG, right? You can self-host your vector store if you're doing it locally and running in your own computer, but again, you have to have a strong computational if you're storing things at scale, right? It's if you have just 10 PDFs, 20 PDFs, go for it. Stay on your drive, put it on a small, whatever it is. But now if you're doing enterprise level RAGs, you have to think of a way to use more of an enterprise productionalized vector store databases. So again, a key takeaways I want you to take away from looking at a RAG is LLM token costs are actually a small portion of the total RAG expenses. What becomes really expensive while holding a RAG is the vector database operations, which become significant at scale. So if you're having millions of data, billions or terabytes of data, again, this will be the one that's going to be the major cost-eating part of your RAG each month, not the people asking questions. It's hosting all that data coming in. engineering time for tuning and optimization of a RAG is actually the hidden cost. So people say, oh, we're going to do a RAG. Let's do it super fast. Let's go. Let's do it. I don't like it. Seems very cost effective than doing fine tuning. You can fine tune a model on previous data, but it's going to cost $6,000, $10,000 to fine tune a small LLM. Meanwhile, a RAG could only cost you $500. And you're like, okay, well, let's just do RAG. But the hidden cost comes from you need then to have an AI engineer, software developer, etc., that can create the evaluation data set and be able to experiment chunking, experiment the filtering, experiment the hybrid search, and also sort of playing around till we actually get the results. So the hidden cost comes from personnel working on a RAG and changing things and adjusting things until something comes out properly. And this is what most people, when they get into these in the enterprises, don't understand, that you need to input manpower into this. That it's not RAGs aren't just plug and play. If you really want really great behavior coming from this, and not to have hallucinations and things like that. There are serverless options for low to medium traffic scenarios as well to increase the speed, but that's sort of one of the main key takeaways I want you guys to think about when you want to propose a RAG. Just think about those hidden costs and ensure that when you do your proposals, you're taking in account that there needs to be some time for experimentations and there needs to be some times for evaluations. And not only evaluations from the AI engineer, because let's say your information's on scientific data, your AI engineer won't know the detailed scientific data. You also would need SME evaluation on your RAG on top of it to ensure that the actual information is correct, right? Okay, so I'll take a quick pause there. I'm going to show you how this looks like on Gemini AI Studio. So let me just pull this one here.
Hey, Louis, before we go very far, I had a question in the chat. I guess I didn't, was not able to understand that well, the hybrid aspect of it. Is it like, for example, if you have in a vector store a column which is specific to a keyword or a filter or something, and plus using the vector store, actual vector store, which is embedded, is the hybrid search, and then using it together is the hybrid search, or what exactly is this? I mean, I didn't quite understand, to be honest.
Yeah, so when you set up a RAG and you have a vector database, you say the RAG to extract your chunks, right? And it'll ask you, how do you want to extract it, right? You have to write that function of extracting that RAG, of extracting the information. And usually it just defaults typically to only cosine. Now when you want to do hybrid search, example, you do hybrid search, it usually depends on which tools or functions. You simply just change the word to a single search to just put hybrid search. And when they put hybrid search, depending on the tools you're using, their language it is, it's going to know that it will know to do keyword search itself and cosine similarity. So you're not going to go in there and adjust your embedding table or anything like that. They're usually pre-built-in functions, and there's limitations of what type of searches there are, and it depends on the vector store. Again, going back to your vector store database. Let's say you're using Pinecone and you're using Elasticsearch. You can then define in your vector store database, use Elasticsearch plus cosine similarity. So you're telling it to use the hybrid search function, and it will automatically know how to do it. So you're not going in there, you're not adjusting more your RAG, your embeddings. It really depends on your vector store database, what search capabilities it contains, and if it's really, and which ones is better for you. So you're not doing extra work to it. It really depends on which vector store database you're using and the different types of searches you can do on that. And you simply just change the functions to say, instead of single, just to hybrid. And that's how that would work.
When you say cosine similarities, that's the one which we have been learning all the way through, which is typical LLM search.
Yeah, when I say cosine similarity, it's a default, right? Default of looking at the embeddings, comparing the embeddings versus the embeddings in your vector store database, and then using cosine similarity to calculate a score between the two and use that score as the top embeddings. So that's usually the default for all of them. All right, so what I'm looking here is the Google AI Studio. Anyone can get Google AI Studio for free. You just go aistudio@google.com to sign in with your Gmail, and it'll give you a free area access. That's where you can play around with and use an LLM. Now, in Google AI Studio, you can choose different types of models. So Gemini 2 is the newest model, and they have a preview section of their latest models. Gemini 1.5, which is their most stable models, and Gemma is their open source models. But one thing I want you to notice here is that when I click and hover over a certain model, you can see that there are input costs and output costs. And you can see a total context limit. So if I look under the input/output API pricing, I see for under 128,000 tokens, it's going to cost me this. For over 128,000 tokens, it's going to cost me that. So it's saying there's two different types of pricing right away. I'm looking at this that it will charge me based off how much data it has. One thing about 1.5 Pro is that it can handle up to 1 million context window. So you can know it can handle a lot. And right now, this is sort of what the gold standard of how long or how big it has. But this is exactly when we look at this is how you would sort of want to look in price, right? So you want to say, okay, if I use this, it's going to cost me this. If I use that, it's going to cost me that. So you can look and sort of price it. Each LLM provider will have to have this. So whether you go to OpenAI, whether you Azure, AWS, you can see that every single one will have a pricing input and output API pricing for this. Now, this Google AI Studio is for free. And you can see in the bottom part where it says rate limits, 1,000 rates per minute and 2 rates per minute of 50 frequency a day. Because this is for free, there are going to be some rate limits of this and how it is. But when you let's say use now Google Cloud Platform or GCP or using Vertex AI, you won't have those rate limits as high. It will probably be lower. So you can then, but again, this goes back to you can't send too many requests to an LLM if you don't have some sort of rate limits of it going, and we'll talk about that as we could going on in production. So if I want to get started, I'll start with Gemini 2.0 Flash. You can see 2.0 Flash is super cheap. It's 10 cents input and 40 cents for output for 1 million tokens, right? So we're looking at 0.000001 cent for 1 token, etc. from there. So unfortunately, no, OpenAI is more for profit than Google AI Studio. Google AI Studio is the only one right now that gives you free appliances to play with Google AI, play with the Google models, and actually give you a free API so that you can use this free API in your own coding. So you don't have to pay. You don't have to pay to do experimentations, pretty much. And they want you to use our models, and this is why they have that push forward too. So when I start here and I say a simple question on 2.0 Flash and say, hello, can you tell me about VSF Club? And I run this. You can see here at the bottom, it's going to tell me something about token count. The token count it's going to give me is 12 tokens from that top part that you saw before, which was my input tokens. Now, without this huge output tokens that it just finally gave me, it gave me a bunch of information about what VSF Club, and although it wasn't right, it still gave me a response. And because it gave me a response, it was a total of 780 tokens. So for me to calculate this, we know that 12 tokens was the input, and minus this 12 tokens minus the 780. So we're looking at 768 tokens for the output. And that's what you have to calculate. Okay, so what did this one query cost me? If I know it was 12 tokens for input, then we know that 12 tokens for input, we know that's 10 cents. So it's 0.000012. And for output was 760. But like, okay, what was output again? 40 cents. So then you multiply you divide 760 divided by that 40 cents, which is going to be like 0.00112, whatever it is, and that's your total cost. So the total cost of this one question, input and output, came to 0.01112 or less than 12 cents or something like that, or maybe less than 10, maybe less than that, right? So this is sort of how you would look at and go from there. And by saying no, this is a tech club in California about helping others get up to date. So it's going to continue going. So this one doesn't show here. Yeah, okay, it does now. So we could see that it added this. So this one I think it was 24, if I remember the number correctly, about calculating this. This was another 700 and something, but we can see here that the total token count is 1,743 now, right? So what it's doing is not only adding this to your output, adding this out, it's adding this plus all this as your input. So whatever happened here now, the 780 plus the 25 is now your input. Now, when it outputted another 680. So then you add the other 680, whatever it was, then you have the total of 1,743 token counts now for your model. So this is how you look at it, and this is how I want you guys to play with it, is to understand that there is, because this is something that has chat history, it is a snowball effect, and only will affect your input, right? You need to carry on that conversation with your model constantly to get that part out. Now, people are like, well, that's too long. What if I want to have a maximum output length? Okay, and you can do a maximum output length. So you can click here on your settings, and you can say, I want to do a maximum of only 200 tokens now, output information. And I can ask and say, can you think of another one? So you can see here, it automatically did something extremely smaller and was able to think of something and respond to me in a shorter way. But why? Because I changed the max output length of only 200 tokens. So I can control that the model can only answer a certain way to help reduce cost as well. So instead of having, remember we were at 1,600 something before, it had the 200 tokens plus this small one. When you add that on, now we're having smaller token counts. And there's a way to then reduce the amount of output coming out and again, help reduce cost. So for you, the whole purpose of this, again, we're not getting too technical, but I want to show you that there is a way to control costs. There are ways to control the output limit of how you can use an LLM and how that's important to know for in a business context, right? And this is something as a functional requirement you can put in, because let's say you do the costing and you want to balloon up, you can say, listen, we're going to maximize the output only 500 tokens per response. And we can only do, and users can only chat 10 conversations at a time. So you can, one, reduce the interactions, reduce the output, and also have input guardrails, right? If they're talking about things that are completely off topic, you can also put guardrails in here to stop responding to anything that shouldn't be evolved about your company. There is no way to prompt delete the history and reduce tokens. You would have to build that out in your backend tools. You would have to say, okay, if the conversation history hits more than 600 tokens, summarize. And this is what OpenAI does. OpenAI doesn't send out all your chat history. It sends out summarizations once you get to a certain amount of limit. So it will use some of your data, some of your direct text, but you'll get to a point where you might ask something again, and it's not giving you the same answer it did before at the beginning. It's because now it's starting to summarize, and it's not giving you, it's not giving the exact details that you put in there before. So again, when you see things like that happening, just close the conversation, start a new chat, and begin again, because now you've started hitting the context limit. And you can see here, because we're using Gemini Flash, the context limit of Gemini Flash is about 1 million. So it can only handle about 1 million tokens, right? So we're about there right now. And other models like OpenAI is 250,000, Claude's only 128,000. So again, there are limits to each of these different models of how much tokens you can use from there. So I just want to make sure you understand that part. So how do you start a new context? Again, you have to create a new chat window. To start a new chat window, you can tell before you jump over, you can say summarize the main points for if you don't want to lose everything you've done. Just summarize the main points of my conversation. Start a new window and just paste in here your chat summary into this, and then start your conversation again. And that way you can keep going and keep going and keep going without trying to lose too much. Yes, Satya. So Yanagish, there is no OpenAI Studio for you to play with. All of it is you have to pay for the. There is an OpenAI Playground, but again, every single time you use the OpenAI Playground, it's going to cost you money. You have to put your credit card in there, and you'll have to use their token limits from there. So again, good thing about Gemini is all this is for free, so you don't have to pay anything like that as well. They give you that information, and also they give you API keys. So you can go to your studio and click Get API Key, create API key, use that, copy that into your studio, wherever it is, and start working and building. So again, that's really great about Google. They really want to push out their products, and it's a plus for people who are now experimenting. Okay, just going back to the slides. Okay. Oh, so before one thing I wanted to show, one thing before we jumped over was agentic tools. So in order to do agentic tools, there are extra costs as well. So I'm going to pull as I'm showing my Google Studio part up, I'm going to show you one more. So in Gemini 2, there's something called I think which one is Pro Preview, and you can see here under use case. This is a reasoning model, right? So you can see that there's models that are normal chat models, and then there's something called reasoning models, and reasoning models are the ones that actually think through problems. So what's the difference? So I'm gonna put here, please explain the theory of relativity to someone in grade 9. So if I were to send this to a normal chat model, I think I would probably have here about 20 tokens maximum of my input. But let's see what's happening now. So it's 13 tokens. So right now, it's going to start thinking, right? With reasoning models, it's going to start thinking more how to better respond to responses. It's understanding the targets, understanding the core concepts. It's going to break down and actually think about how the best way to respond. So it's going to respond here. I want you to look at this 1256 here, and then when it's finished writing, we'll see what happens. Okay, 2,473. So what happens? This was 13 tokens. Because you're using a reasoning model, it generated text of how it should respond and how it should be broken down. It created these reasonings of 1,300 tokens of how to reason through the response. Once it was able to reason through the response, it took the reasoning as an input and then used that to create an output. So now your output is done and created over 1,000 tokens here. So then your total token count that you used was 2,473. Now that's where you have to think about it. Is it really necessary to use a reasoning model every single time for simple questions? You definitely want reasoning models for more harder questions to understand. Okay, there's a couple questions in the chat. So every single time ChatGPT provides answers, it also needs to do the summarization. Additional cost for future usage, correct? So again, yeah. So again, if you're using API costs, if you're asking it to provide a summary at the end, you will then do it. If you don't do this, OpenAI is eating the cost of the summarizations, right? So you don't have to worry about if having a chat conversation, building this up, if you're using their UI, they eat the cost of doing the summary, their chat history, etc. You're not touching any of that stuff. But when you're in production and you're just using OpenAI's key and you're using that, you'll have to provide your own summary, you have to provide your own things, and that becomes an additional cost to think about. There's something like collaborative reasoning. What do you mean by that, Satya? I'm not sure I've ever heard that collaborative reasoning.
So the thing is, we have okay. The thing is, right? Okay, like say example, there are 10 different ways the Gen AI or sorry, the Google AI's any of the models, right? It generates an intermediate. Like say example, it gives 10 reasons, but like I want the model to think in, like say example, out of the 10 reasons, I want it to think only go in a certain path, like pick up the top 3 reasons kind of a thing. You understand what I'm saying? Like as that is a collaborative, there is collaborative filtering, collaborative reasoning, collaborative search kind of a thing, right? That's the reason. That's
so
what.
For sure, and that can be part of your reasoning process, right? So good thing about this too is that you can also add system instructions, right? This will be part of every single input that you're talking about. And I can say from each of your reasoning that you do, only choose the top 2 to generate your output. So I can specify this as my system output. So when it starts reasoning and asking questions, it's not going to go through the 10, it will still need to output the 10 reasonings that you have. And then it will just additionally just use that as an extra goal. But in the end, it won't save you tokens. It might generate more tokens because you're not asking it to do an extra step on top of it. So the reason why I'm just showing this again, I think this the whole part of this is that when you choose models that have more reasoning capabilities that can think about it, there's the hidden cost of the model reasoning that you need to input into your model in order to make it smarter, right? So you have to be very careful of which models to use. And a good example of this could be is having an orchestrator, right? If you have a question about something very simple, you can send this to a normal chat LLM, right? Normal chat LLM can respond back and forth. But if we require something that require more complex thinking, requires more mathematics, or something that requires complex problem solving, you can send that orchestrator to send it to a reasoning model. And that way, it might cost you more to have an orchestrator that's doing tokens and looking back and forth. But in the long run, you'll be saving money because you're not sending everything to your reasoning model and therefore increasing the cost for this. And reasoning cost of a reasoning model is way more expensive here. So you can see here that the output of a reasoning model is $10 per million tokens versus we were looking at Gemini Flash was 40 cents, right? You can see there's a huge difference in terms of cost between a normal model and a reasoning model, and the inputs and outputs, because again, you're using more compute. The model is processing more and giving double the output, right? Because it's the output of understanding what's happening and trying to develop a game plan, and then the output of after creating the game plan, your actual real output. So
Luke, one quick question actually. So who really uses the reasoning model? Because in a conversational AI, right? Probably it makes more sense to know the reason how it is coming out to be. Like say example for an agent, not really chat agents, but really agents, right? The silent agents or background agents, whatever you want to call it as, correct? What is the point of reasoning?
a reasoning model is to make your model smarter. So an example would be, I think I show this in the Gen AI 101 course, is that if you tell a simple model, I have a cup and I have a cup with a ball in it, and I have to flip it down. I flip my cup down and bring it back up. Where's the cup? A chat model is not it's not a
Right,
reason.
I understand. Correct. I understand that. Like what I mean to say is, yeah, sorry, it's a kind of an okay. Here it's outputting it for you to see, for you to visualize it, and then see. The thing is, I see the reasoning model as 2 things, right? One is explainability. If I'm looking at it, like for example, a silent agent is probably firing 100,000 requests, right? do I really care, like what reasoning it is doing? Capturing the output of the reasoning is where I'm leading to, I don't really care, like, sure, I want you to use reason it, but I don't really care about the output unless the reason where I'm leading to, where I'm leading to is, do people use the reasoning for example, your metrics? You know what I'm saying? Like as in metrics evaluation, how well my, I'm paying money to the ChatGPT or whatever it is, or Gemini or whatever it is, right? But then is the reasoning, like right to be able to show in metrics for my customers, right? Like I'm serving my customers, 70% of the reasoning is right. For that kind of metrics, do you use it? Capture the reasoning as well and then use it later. Is that how it is?
An example to look at this, I will say, is a mathematical formula. All right. So let's say in a normal chat model, you use quadratic equations, and it's like we solve this response, and you're not seeing the reasoning. It's coming out response is -2. You have no idea how it got there, and it's completely off. If you grab that same mathematical equation and you give it to a reasoning model, you can see the models. Okay, first we're going to grab the quadratic equation. We're going to do this. We're going to do that. Oh, look, there's it's squared here. So therefore, I need to square my model. And then after I square it, I'm able to get this. I'm able to get the response where the answer response is 4. So for more complex thinking, more step-by-step process, you can see that a reasoning model will handle more complex questions like mathematics, like coding. For problem solving, puzzles, things actually require step-by-step thinking and breaking it down into smaller steps and actually responding, you would use a reasoning model. And then if there's something wrong with the reasoning model, you can definitely go back and say, oh, it's messing up on this. It's all because it doesn't know the rules of logarithmic functions. So I go back to my prompt and say, here's are the rules of logarithmic functions. Please solve again. So then you feed it the rules. You can see that it learned from the logarithmic functions, and then you can see it step by step able to solve the answer properly. So you definitely want reasonings is to solve harder problems that you simply that's something that's not just text generated, right? You definitely want something that's used to solve more harder problems, harder issues, coding issues, etc. that a typical LM generation model won't do for you. And that's why you definitely would use a reasoning model.
I have a question. So it makes sense in terms of like, say you want to know how a problem can be solved, right? Maybe GenAI can do that. But if you're doing the problem crunching and then trying to get you're trying to do a mathematical solution, would that be a good use case? I totally understand. I get why you need the reasoning model. So that's a separate question. But I just got curious about the problem solving aspect.
Yeah, so I would say reasoning models are made for problem solvings. Like chat models are made for quick question and answers, and reasoning models are made for solving problems. So let's see here. What we can do is in Google Studio,
mathematical problems, or
it could be anything. It could be word problems, it could be puzzles, could be coding. For an example, I'm going to show you a difference between a normal chat model and using Gemini 2 Pro preview, right? So I'm going to compare these two models. I'm going to ask ChatGPT here to sort of create me a quick riddle. Create me a riddle.
Luis, you're sharing a different screen.
1 second. Flip me over. Oh, it switched me over. 1 sec.
Yeah, we can see it.
Okay. So I'm going to go here and I'm going to put this riddle here. I speak without breath, I move without legs, I vanish the moment, to this in your head. So again, I'm going to ask it a riddle. And then I'm going to ask Gemini Flashlight in 2.5, and that's the exact same riddle, and what would happen? So right away, 2 seconds came in, they saying the end of the rule is a lie. So, and the difference between a reasoning model is what's the response? So again, it's going to go through the riddle, analyze, look at the candidates. It brought down to 5: lie, speak, rumor, secret, fear, illusion. Compares lie and rumors. Rumor feels slightly broader. Got into it's a lie. So in ChatGPT, I think it gives it the answer is a rumor. So although it says this sounds like a rumor or potentially a lie, that is the most correct response. The ChatGPT said the answer to this is a rumor. Now you can see here that the model here attempted to respond the answer, looking at it quickly, give a response, but didn't think about it. It didn't think about that breakdown of, okay, I want to compare this to first before responding. I want to look at this responding. So the reason of a reasoning model is to think of harder problems and look for the solution better. And it doesn't matter if it's a mathematical problem, it doesn't matter if it's a riddle, it's a puzzle. It breaks down harder to think questions and tries to respond to them. So I would definitely use reasoning models to help create business cases, because an LLM will just generate your responses, but a reasoning model can think like Steve Jobs in an interview with me, criticizing my business case, and it will think and reason and try to reason as him before it responds back to you. You can definitely use this in your code base. Hey, I'm stuck in my code. I try to use Gemini 2.0 Flash. It's messing up. Can you think of reasons why my code is not working? Okay, let's break down your code, and that you'll see the reasoning break down the code for you and help you find solutions. And the reason why it's doing this, it's because it's doing chain of thought. It's going to break down your responses into smaller sections, solve those smaller sections first before getting to the final response. Meanwhile, then in a normal chat model, you're just solving everything at once. And hopefully that answers that quick question. I got to continue from here, but definitely something we can talk about once they get deeper dive into. But the reason why I wanted to show you this is because when you do stronger models that do have reasoning, there's additional cost to it. And same thing with using tools. And I'm going to call this an agent here. I'm going to use something called searching with Google Search. And this is what we call agentic AI, because I can say here, what is VSF Tech Club? And click run. Oh, okay, switch the model, but let's see if it's. Okay, perfect. So remember before, it couldn't really answer what is VSF Tech Club, what it was. I said, no, it's from the Bay Area, everything like that. So it's like it gives me now, because I used Google Search, I was able to pull in for information and feed that to my model. It was able to respond in a better way. And this is what we call agentic AI, because what we're doing is we're just feeding information, going and telling it to pull information from a tool and bring it back. So typically like RAG, where you're pulling information from storages, and in agentic AI, you're pulling from tools instead, whether it be Google Search, whether it be from your enterprise status systems, whether it be from UPS, whether it be from another API that you have calling. Agentic tools is where you go in and you use tools to add information to your LLM. And this is why if you were to ask what day is it to OpenAI, it's gonna be able to respond to the date, because it's gonna pull a tool that's going to tell you what the day is and give it back to you. But if you have an LLM that's boxed and has no access to any tools, and you ask it what day it is, it's going to tell you the day that it's trained, because it doesn't know any more information other than its training data. And this is why you use agentic tools to help you do different cases and look from there. So again, I just want to show you that there's different agentic tools you can use that will cost more money, but it'll help you improve your workflows. So let me switch my screen again. So when you look at agentic AI cost analysis, the most majority of the cost of using agentic tools is the tools API cost. So it's not the LLM that's going to cost.
Louis, so we are still seeing your browser.
Can you see PowerPoint now? Yeah.
Thank you.
So what's going to cost mostly when you do LLM calls is not the LLM calls API. We saw that super cheap. But what's the cost is the tool API calls. So if you're using Google API, that's going to be a cost to use, and those are more expensive than LLM calls. If you're using a code API that goes and codifies everything for you and then brings it back to your LLM, those are the real costs that you need to watch out for. Those tool costs are the ones that really drive up when you do this. So when you want to say, hey, I want to build an amazing chatbot, I want it to go and pull information from here, I want to go and pull information from this, and I want to use this API, and I want to get the information from the weather, and I want to get this information. Yes, you can do it, but you have to know that these tools will drive up the monthly maintenance cost because these APIs aren't free. Like no provider is going to give you an information for free. And they'll say, okay, well, I'll give you access to my weather API, but it's going to cost you this much to use it every single time. Or it's going to be cost this much monthly to be able to run a certain amount of queries per month, whether you use it or not. So when you do agentic AI, where you have to think about the cost is the tooling cost. And that's the main point I just want to push overhead. There's different ways you can also better your responses. So I mess up my spelling on a chat, or some users are completely misspelling words, not putting context or anything like that. You can do something called query rewrite, which will take when a user asks a question, you can then use an LLM to rewrite the user's query to remove grammar mistakes, spelling mistakes, and add context to it to make it a better part for your RAG. And you can add that to your agentic tool cost, right? So just an example of a tool, it's query rewrite is example of an agentic AI because you're going in there, you're doing changes and then adding that back into your RAG workflow. So the cost of doing something like this, let's say you're having a tool API cost that costs 3 cents per call, and you're having 50 calls a day, right? So that's going to be a monthly cost of $45. If you have query rewrite, again, LLM costs are super cheap, so you don't have to worry about that. LLM responses, super cheap. Hosting the model on a production grade server, again, it's a fixed monthly cost, could be $20. And if you have any monthly overhead changes on the code, $5. So looking at agentic AI, let's say a simple 50 responses a day tool cost, again, comes to $70, where over 60% of that will come down to your tool API calls. So as much as people think it's cool, let's do agentic AI, let's do it. That's great, but think about what the tools are being called and always remember that there is a cost to use external API tool costs that are out there. Unless it's something that you built in yourself, then that's it is. And again, I just want you to think about when you are not looking at RAG, you're looking at agentic tools, there is the tools API cost is what drives up the real cost of this. Okay, so let me see if I can just make this a little bit bigger. So like I said before, I think this is just an overview of what I was saying before. Tool API cost comes about to 64% typically of hosting agentic AIs, of what drives up the cost for this. LM token usage is very negligible, so 0.2%. And also you have to remember that the major point of an LLM should be the hosting orchestration because you want to make sure you're reliable, and that should always be the top part. But that's the only things to remember, consider. So consider this as when you do agentic AI tools, where it's calling from, and is there a cost to do this? Okay, all right. So looking at the time, I gotta go through a couple more of these slides, but as you go through and you're using these things in your enterprise business, there's 2 ways to call from an API. And one is the typical one that everyone uses is called pay per token. And this is what we saw we had opened up Gemini and we looked at the 10 cents, 40 cents, 80 cents, that all the cost is pay per tokens. So what's the advantages of using pay per tokens? They're predictable. You only pay for what you use. You don't have to worry about setting anything up, and they're very flexible. But the disadvantages, again, if there's people going in there throwing in 30 pages and someone decides to one day, it'd be a good idea to input my whole Harry Potter book and make me an essay from this. If people are doing that, it's going to drive up the input, drive out the output. Someone's constantly having conversations and building out thousands and thousands of paper, thousands of outputs. That cost is going to scale linearly, right? As you multiply, 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 multiply. It's difficult to forecast monthly spend. As much as you can say, we're going to have 50 conversations a month, maybe there's someone who just has a really bad day and is just going to town on your chatbot and it's using 400 conversations just because they're bored, right? You can't forecast that random user going in using your chatbot. So it's difficult to forecast that monthly spend. When you do paper tokens, there is no economies of scale. So you are sending one response in, sending another response in, and if someone sends 15 responses in, it could be your chatbot was always responding maybe 1 or 2 seconds, but because now there's 15, 20 people shooting a message at the same time, now it's taking 5, 10, 15 seconds for a response because there is no economies of scale as you continue doing this. There's potential for unexpected spikes in cost as well. So that's the only thing I want you to think about when you do something called paper tokens. So when you're going in and you're using these third-party providers and you're using for enterprise systems, you'll see that this is out there. So what is recommended? As you do paper tokens, it's good enough and it's good enough to go through who are experimenting and doing things like that. Yes, and people who rely more on vibe coding, etc. How could we now, what is something that's really recommended? And again, I see this everywhere. And what's really recommended for when you use Go in production is something called provision throughput. And provision throughput units are recommended when you're doing something in production that's going to require stability, scalability, and fixed term commitment. So what is a throughput-based model? You're pretty much leasing LLM model that's dedicated just to your enterprise. And you are having this lease on this LLM model that gives you the following advantages. It's predictable monthly spend. So it's a fixed cost per month. It doesn't matter how little, how long, how much more. If there's 1,000 people going at it versus 2,000, 5,000, it doesn't matter how much they're using it. It's gonna be a forecasted monthly spend each time. There is economies of scale. So let's say you're having 100 users, but the next you have 500. And in a throughput-based model, it will scale out and give you the proper concurrency for all users. It's better consistent for workload volumes and has a lower cost at high volumes. So what's the disadvantages of having throughput? You have to pay for the reserve capacity. So example, let's say could be up to $1,000 to $8,000 a month, just having this reserve capacity just for you. There's potential for underutilization. There's a potential that you might only have 60 people use your chatbot that month, and you paying all that money and you're really not getting the best bang for your buck. There's higher upfront commitments. Again, you're paying all this upfront, right? And it's less flexible on variable loads. So again, this is where something you have to look about. You have to look about your load and balancing of when you have these models. Now, what's good about these throughputs is that they promise optimizations. So let's say you're doing a throughput model and it's $8,000 a month you're paying for. You're guaranteed to have 1 query per second responses, and it doesn't matter how many concurrent users are using this. So the throughput, for example, your throughput model can handle maybe up to 300 users or 500 users at a time. It means it's promising you that every single time those 500 users will log in. It doesn't matter if they're responding at a millisecond. These throughput-based models will promise you 1 query per second responses. And that's huge, right? For people who are large businesses, who have large context and want to go and show that they have great customer services, people go through these throughput-based models in order for them to provide superior customer service doing this way, right? So again, they have a maximum sometimes. So sometimes they have a maximum of 2.6 million queries, which I doubt that everyone's using enterprise chatbots to do that high. And let's say in 100,000 conversations a month, right? So the monthly cost for this is $8,000 a month, regardless of usage. And if you were to compare that to the cost per query, it's only about 0.8 cents, right? So when does it make sense to do something like this? You need to look at your average conversation per month. You need to be looking at, okay, what is my break-even analysis? If I look at my chatbot and I see that I'm having over 300,000 conversations, does it make sense for me to keep pay per token? I'm doing my own load and balancing. I'm able to handle more concurrent users. I'm able to open more GPUs. I'm able to use different LLMs. I'm able to load it myself. I'm not having any issues, etc. Like it's good enough. I'm having 300,000. It's only going to cost me $7,000 a month. So therefore, it makes more sense for me to keep my price per token because I'm doing my own thing and it's costing me less than $8,000. Therefore, I'm fine right there. But now that we see here that after $400,000, 400,000 conversations are happening, that means that it's going over that limit, and it can handle the spikes. So over 400,000, we can see that the cost is 8,000. So if you're doing price per token at 500,000, it's going to cost you 10,000. At 600,000, it's going to cost you 12,000, right? So it makes more sense in terms of price point if you go over that 350,000 limit to switch to a throughput response, because again, you are seeing that you're spending all that money anyways, and might as well switch to throughput and save yourself that extra $4,000 you would be spending that month, right? And again, it goes back to that way. So throughput query doesn't matter. You can throw it whatever you want at it, have response to everything like that. It's based off queries and not tokens because again, throughput model, you're having a dedicated leased model to you, getting thrown conversations at it, and it doesn't matter. It's like a free for all, right? So you can use it as much as you want, and it's always going to be that one fixed price. So you're just gonna give you an example of when you do your own cost analysis and you're going to production. Again, you need to think about what is the business requirements? Is there anything to do with latency? So if they're saying, you know what, if it's under 10 seconds, we're fine with that, then don't worry about throughput. We're more worried about how many concurrent users are going to be using this. But now they're saying, hey, I actually want responses always to be under 3 seconds. Hey, I want my responses to handle more than 60 people having a conversation with my chat, or 100 people, or at least 300 people happening at the same time. You need to be able to offer that. Then you can say, okay, I can do something that's less than 1 minute. I can do one question per second. I can offer up to 600,000 chats, whatever it is, for 300 people, but you have to go through throughput. And this is what's guaranteed. And if it won't break down, you won't be sharing the LLM with anyone else. You'll be doing this, and this will be sticking to yourself, right? So this is where you need to go look at what is really the usage of your model. How many queries and is there any KPIs for latency? And that's something when you design and you're designing a proposal, you need to be thinking about it. And again, a lot of people will say that if you are a business and you are having a chatbot and you're having something that people can respond to, and it's your face of your company, it doesn't matter that you want to save the extra $3,000 a month. You should always have throughput, because again, you want each customer to experience super fast latency and have a good customer experience regardless of what happens. Okay, switching off from there. Now that we had a conversation of what are tokens, what are the costs, why there's different ways to do APIs, I'm going to switch over to something now called into local models. Sash, before I jump in there, you had a question?
So, Luis, you mentioned that the throughput pricing is per query and not per tokens. Do I also have the choice of my own model?
Correct.
Like,
So
for example, I just choose all the reasoning models.
Yeah, you can choose a reasoning model if you
All the
want.
queries and tokens, right?
Yes, but remember, if you're using a reasoning model, I'm sure whatever provider you're going with might charge more. It might not be 8,000, it might be 12,000, right? It might say, the reasoning model. Reasoning model for this model is going to be $12,000. Or yeah, it depends on which model you use. They'll have different price points for throughputs.
Okay, so the pricing is the one that you just put there up is just for an example.
Just an example. You have to go to AWS, you have to go to Azure, you have to go OpenAI, and you have to look what specific model you want, and I'll show you price per token, and I'll show you the throughput version as well.
Understood. Thank you.
Nigesh, you had a quick question?
Yeah, I wanted to find out like if you were to reduce, sorry, let me rephrase. So if you're using multiple sessions, right? I talked about like, a use case where you would hit the server and the server would be parallelly making the different sessions, and then so that the context doesn't get mixed up and those kind of things. So can you tell how would that typically work? So basically, for every call, you can say that whether it's a session less call or session with session and those kind of things, or how does it basically make it safe between the different users?
For sure. And so this is probably going to distract from today's lesson. I only got half hour left, Angish. If you are there on Wednesday, this is something we can definitely, it's gonna take more than 10 minutes to explain. So if you're gonna be on we can go and we can do a deeper dive on that for sure. It's just it's gonna take a little bit more time than 1 minute to explain how that for sure. But no, great questions. Just make sure you write it down so we can remember and we can have that discussion.
Sounds good.
So what are parameters and models? So one thing I want you to think about is when you're looking at now running local models. So again, we talked about APIs, and APIs is basically the fastest way of using a model today, right? You don't have to load the model, you don't have to do anything. But let's say you want to load a model on your local drive. So let's go on a conversation of which models to load on your computer, or how would you use a model in enterprise and how that works. So you can see that sometimes there's different types of models that are out there. So there's models of 8B, 15B, 60B, and you can see Llama 3.1 8B, Llama 3.1 70B, Llama 3.1 405B. So what does that B mean, and what does that mean? So those B's is the amount of parameters that are being used in models. So think of parameter as a tiny knob or a setting that AI uses to make a decision. Each knob adjusts how the model interprets the language, pattern, or relationships. So sometimes we talked about this on Wednesday, is like even in a neural network, each node is like a subject matter expert of the subject. So let's say a knob could be let's say how it understands a car relationships, or another knob could be of how it understand what cats are. Each of these have different models and knobs, and depending on more knobs it has, the more understanding or the more knowledge it has around a certain subject. So one thing I'll focus on today is talking about Llama 3.1 70B model, right? So that's a really great model. So what it means, it has over 70 billion knobs it uses to process and understand data. The more knobs it has, it can handle more complex patterns. It can recognize more detailed and nuanced, but also require more power, more time, and more memory to run, right? So because we're now using a 70 billion parameter model, it's going to require more power, more things to process versus an 8 billion model parameter, because it has less parameters it needs to adjust. So real world analogy, imagine teaching a child versus a team of 70 billion micro specialists. A smaller model is like a child with crayons, and a 70 model is like a world-class design team with every tool imaginable. So the more parameters the model has, like I went back, the more context it can have, more thinking process, and more relationships and understanding of the world it can have. So why should you care? Bigger does not always mean better. It also depends on the tasks. So the one example I gave on Wednesday was, let's say we know that OpenAI has their ChatGPT 4o model. It doesn't say how many parameters it is, but we can assume that it's at least 405 billion parameter model because of how smart it is. Now, DeepSeek came out and trained a model based off OpenAI. So they went to OpenAI, they started asking questions, and they created a training data set. They used a teacher-student model, which they grabbed distilled information from their GPT-4o model, used it to create a data set, and then from that data set, used it to train their DeepSeek model. Now, because the DeepSeek model is only I think it's only less than 12 billion parameters, it still has the smartness, it has the ability to answer super hard, complicated questions at a very high accuracy rate. So how does it do it? Because it used clean data, it removed noise, it removed extra parameters it didn't need to have. They focused on on certain things. So although it's a smaller model than GPT-4o, it can be more accurate and it has better results simply because it was trained on better data, trained on better parameters, and it didn't have any messy information. So that's why it's always saying bigger does not mean always better, because there can be a smaller model out there that could be 8B, could be 4B, and that could be smarter than a 70B model, simply because it was trained on better data. Larger models like GPT-4o, I said it was 405, but GPT-4o, we think we're assuming 70B because, again, OpenAI hides how many parameters are in their models. It can handle things like complex writing, code, summarization really well, but they also cost more to run and need stronger machines. So how most people do it locally is that, let's say you have a 70B model, you need to have a good space of how that works. And so an example I'll do quickly, I'm going to log into Hugging Face and show you the area of how big that looks like. Let's give me 1 second. So let me share my screen. So we know that these things are open source, right? So that means models like Llama, which are open source, means you can actually download and view them on the internet and use them on your local computers. So this 70B model download was about 1.1 million already, right? So like I said before, this was trained on 70.65 billion parameters. So it has a lot of these different knobs of collections in there. Llama has different sizes on its models, 8B, 7005B, 405B. So what does that mean? 70B doesn't mean you need 70 gigs of memory. How big this model is if I go to files and I can see that the model is broken down into different shards, right? So 1 shard of 30, 2 shards of 30. And you can see there that each one is about 5 gigs each. So if I do 5 times 30, that means just to download this model, I need 150 gigs of memory just to download this 70B model, right? That doesn't mean the space I need to load it, to optimize it, to run it, etc. And if I look for a 405B model, look at 3.1 405B, and I go to files and version, let's see how much space I need. So this one is showing 191 shards. That means it was broken up to 191 sections. Now I multiply that by 5. That means I need 1,000 gigs of just memory space just to host this on my computer, right? And we know that right now 250 gigs of SSD is probably $300, $400. So if I'm having to load a 1 terabyte SSD on my computer, again, just to buy that one SSD for that 1 terabyte could be $500, $600 just for that 1 terabyte. Could be more. I forget how much it is now. Prices have changed, but that's just to host it. You still need to have, remember, space for your computer. You need to run it.
Yeah, of course.
There's someone had a question.
Oh, sorry about that. Yeah, I was just okay, but I do have a question. So typically, won't you make a request to a server versus hosting this? Or I guess it's a choice always if you want to do that. But how would you decide and then go with it?
Yeah, so this is, I'll talk about that as we go on, but this is talking about, so this one, so we looked at what it means to do APIs. Now we're looking at what would it take to host on local on your own enterprise system or your local computer. Now, the reason why you would do this is, let's say someone has really private information and they don't trust Azure, they don't trust OpenAI, they don't trust Claude, that they won't use the data to train their own data, right? Or give away enterprise secrets. They want to keep that data internally. So this is why people would then want to host a local model on their own computers and drive in order to run this information.
Makes sense.
All right, so I'll share back to my side. So we saw that in order for it to be running, yeah, even to fine tune that model is going to be more expensive as well, right? So how do people run these machines? How to run these models locally, right? So let's say even the 8 gig model, I think it's 8B model. Let me just check the size here quickly. So I just going to do like a quick file version, 5, 10, 15, 20, 25 gigs of memory you need to run just even for a small 8B model. So how do people run these locally on the computer? You can see people running LLMs all the time on the computer. Like, well, how are they doing this if they need a lot of space and memory? So they do something called quantization, which is pretty much grabbing an AI model and then compressing it. So you're removing layers from these models. So you're making it smaller and faster and runs on devices that don't really need crazy GPUs. So what happens is when you have and you quantize these models, think of the full model like a super high resolution photo. It's crystal clear, but heavy to store and slow to load. Meanwhile, quantized model is more like a compressed version, loads quickly, takes less space, but you lose some fine details, right? So you're not getting that super high quality 4K resolution. You might getting 1080p resolution on your picture, right? You're not getting that 4K, but if you're willing to sacrifice that extra special quality, like, oh, no one's gonna really notice, then that's what people do to quantize, right? So why local users use quantized models? Because they usually, if you're going to run a 70B Llama 70B model, we'll talk about later on, you need to have expensive cloud services, big GPUs with lots of RAM and tons of electricity to run it. So with quantization, running an 8B model, people can run this model on their local laptop PC, get faster results without paying cloud costs, and use it offline, so private and secure. So if you have an 8B model and you quantize it to a 4-bit version, this model can now only be 3 gigs of space. And let's say you have 16 gigs of RAM. You can now run this 4-bit version of your model really fast, and you can get a response between 20, 30 seconds versus paying for the full version and having that taking a lot of time. So what's a trade-off of quantizing a model? Quantized models don't always perform as well. They may lose accuracy, especially in tasks that require deep reasoning and precision, can sound a little bit less natural. What I've experienced as well is sometimes they don't have that much intelligence. They're not that smart. They don't reason that much as well. After you slowly, like you can change it to a 16-bit, 8-bit, 4-bit, 4-bit, smallest you can go down to compress, but you'll see it struggle to answer even simple responses. So in practice, 90% of tasks like summarizing, answering questions, casual chat, you might not notice a difference quantizing a model. Like you'll say, hey, how are you? Hey, how's it going? I'm doing fine, blah, blah, blah. But if you're doing deeper analysis, you want to generate long, coherent stories, you want to write production grade codes, this is where you'll start seeing issues with your model. So there's a really great article on Medium that someone went in and actually started comparing the different ways of evaluating what happens when you're to run a quantized model versus just using just a typical API, full-blown nudge models. So there's different scores you can use. This person used BLEU, which is evaluates the accuracy of the language model by measuring the n-gram similarity scores. R1 calculates overlaps between the information and the RAG. Same thing with RUGE2, and RUGE-L is a combination of RUGE1 and RUGE2, and it uses a BERT score, which is used word-based comparisons. So doing this score, we looked at how Llama 3.1 8B quantized, remember, is compressed to 8-bit, how well that worked. Microsoft 5.4, 4-bit compressed, how that worked. They used the two local APIs, the GPT-4, GPT-3 Mini, and DeepSeek 14B quantized to 4, and how each model responds. So you can see here that when you quantize it to 4B, which is the smallest compression, it's not getting as high accuracy. When you compare it to the 8B, the 8B is getting better results, right? That's like half the quantization of it. They didn't do a 16-bit quantization in here. I'm pretty sure it'll get higher. But as you can see, as you compress the model, the scores on certain RAGs are getting lower. And so here you had a question.
Yeah.
So
Yes.
yeah.
So question to you is, you mentioned that these models when you showed on the Hugging Face, right? So my understanding is all these are persisted into SSD, but when you're non-processing, when it is a prompt is queried, I think these are all loaded into memory, like RAM
Correct.
or whatever, flash memory or somewhere before it's processing. So you said that 120 byte. I mean, how does this work? So do we need to have a flash memory of that size that model has to be loaded, or how does that work?
Exactly. So when we looked at Llama 7DB model, right, we saw that was 150 gigs just to download the model. So you need that just on your space. But when you unload the shard, you need to unload it on a GPU, CPU space, right, or virtual RAM that you have. So you would need to at least have, I usually say a rule of thumb is 50% more than what the shard looks like. So if you have 150 gigs RAM, of 550 gigs of storage of that model, you would need at least 200 or 250 gigs of RAM so the model can then be unloaded on there. Then once you have that unloaded, you would need extra RAM to start doing inference on top of it. This is why people usually go to large GPUs, because GPUs usually have 100 gigs of space to work with on it, and then they buy another one, they buy 2 or 3 or 4, and start running these inferences from there. But I'll go to that on the next slides of the cost of running something like that as well, and the hardware you would need to run something that big.
Thank you.
But what I'm showing here is when you quantize it, let's say we're doing the Llama 7DB and we quantize it to an 8B or 4B quantization. Instead of doing 250 gigs of RAM to run it, you may now only need 60 or 80 gigs of virtual RAM to run it, because we're cutting off layers and we're compressing it and compressing and compressing it, so they can be able to run on your local drives. Now, what I'm trying to show here is that yes, we can compress and you can make it run locally. But you can see here through the different evaluations as you go through different ones that they're not as smart as the full-size models. There's always going to be some sort of difference. It's gonna be able to get something as close. But again, what I want to show with these charts is, and I think the final one is the most important one.
Why is the performance low? Because they removed some of the tokens when you quantize, or why is the performance low?
The performance low is because you remove layers. So when you have quantization, is like you're removing the top layers of attention. So each LLM is built on different types of neural network layers. And when you go and you quantize this, you might be removing 10 layers or 15 layers or 30 layers, the top layers of the model. And as you go smaller, without the extra layers, it's not as thinking as through, right? Because remember, think about each parameter is its understanding of the world, and each layer may contain 15 or 20 different types of knobs or 20 different parameters in each layer. And as you're removing each layer and each layer to come down to these, then this is where you would grab that and be able to do it itself.
And
So
do we have control on which layer should be, when during quantization, which layer should be removed, or it's the tools that decides?
So if you are a really smart LLM technology transformation person, you can know and pick and choose if it's open source. But if you're typically just doing it yourself, you usually have a transformer model or an import model that chooses it for you. They usually choose just the top layers. So you can just say transformer fit 4-bit, right? And then it would change it into the compression for you. For you to go in there now, then you would have to, like, for you to remove certain layers, you would have to understand how each layer works, understand which one's doing, and then when you remove them, you might break the model as well, right? So it's better just to have something that's already that knows which ones not to touch from the architecture layer. So, yep.
What is the downside of removing few layers?
Sorry, can you, I can hear you that well. What was your question?
Yeah. What is the downside of removing few layers? I see there are few gains of saving the memory, but what's the downside?
Yeah, so that's what I'm trying to show in these charts. The comparison of doing something that of quantization versus not quantization is that as you remove layers, you are getting better performance. You don't have to spend as much money on GPUs. You don't have to spend much money on getting a huge rig set, but there are going to be some sacrifices to how well it's going to reason, right? So if you need something very if you need something that's very smart and that needs to analyze and actually think about what to do and respond, then quantization won't be the best tool for you. Although it might, and again, this is something where you have to evaluate, right? You create an evaluation spreadsheet, use an OpenAI API, use Google API, and then use two local models, one quantized at 4-bit, one quantized at 8-bit, and then run your evaluations on 4 on how accurate it's able to respond, how well it's able to respond, etc. As you build up the evaluation sheet, and then you say, well, I don't want to, like, I can run this locally, and I'm only receiving 10% less accuracy on than GPU4o. Can I live with 10% accuracy? Can I get, that means if I'm getting 90 out of 100% response to right, is that going to be a deal breaker or not? If it's not, then, well, look, makes sense. I can run this locally, save myself the money, and go from there, right? But if you're seeing 40% drop, 50% drop, quantizing the model, then you might see that, well, maybe quantization of the model is not the best idea. So that's
Can we have the control, like, okay, which layers to be removed so that, like, I mean, which layer works for what purpose?
Yeah, and like I was saying that before, in order for you to decide which layer needs to be removed, you would have to have maybe a deeper understanding of how LLM infrastructure works. If you can understand the parameter models and where each one lives and works, this is where people are having issues with LLMs because, again, LLMs are black boxes, right? So you don't know specifically which layer has what and which information has what. So when you do quantization, it doesn't really touch the main body layers. It usually just hits the top layers, the top upper levels of the LLM. And this is what you use to fine tune a model, right? When you fine tune a model to add extra information, you're not fine tuning a whole model itself. You're fine tuning the upper layers of a model because these are the ones that are affecting the final output, and you're trying to add more information to it. So just like when you're fine tuning these models, you're quantizing and you're removing top layers. You might be removing 1 or 2 layers, 3 or 4, depending on how you're compressing your model from there. So this is where I just want to show that when you have these models, when you do your manual assessments and looking at it, how important is the accuracy, right? And is accuracy more important than cost? Because if I'm using GPT-4o's APIs and I'm getting 70% of my responses correct, and then I'm using Llama 3.1 AP and I'm quantizing it to be that, I'm seeing I'm getting a lot more incorrect responses. Can I live with this, right? Can I live with this response? Can I live with this type of performance? Is it really going to affect my model at all going from there? So I think you had a question, Nagesh. You mentioned parameter size is anything to do with features. So yeah, exactly. So remember, right now I'm saying that each parameter is like a knob, right? And these knobs have features in them that are about concepts of the world or concepts of it that was trained on. So these features could be the understanding the concept of mathematics or understanding the concept of physics or understanding the concepts of shoes, understanding the concept of this, right? Like the LLM has to build a sort of a world model in itself for it to understand how to respond, right? If you're like, what will look good with my dress today? Well, you will look good with earrings, with necklaces, stuff like that. But for it to understand that, it needs to understand that you're talking about fashion. If you're talking about fashion, you're talking about jewelry. You have to be talking about jewelry, you have to be talking about products. All those fashion, jewelry, all those things are knobs inside the LLM because it needs to have more information. So the more knobs it has, the more knowledge it has, right, of different aspects from there. Okay,
Hey,
so
Luis, the quantization is mostly for the LLM model providers, right?
this is
It's
for example, and this could be for yourself too, right? Let's say you want to run an LLM on your computer locally, right? And you wanted to summarize information because you don't want to pay a cloud provider, you don't want to pay API cost. You can run Microsoft 3.18b quantized, right, on your computer. Let's say you have 60 gigs of RAM. You can download this model yourself, run it locally, and then run your LLM stuff using this model, right? And you're not charging, you don't have to pay anyone anything. You're running it locally on your computer, and it's doing the things you need to do, and it's only staying on your computer. You're not sending anything to the internet. It's being everything run local. So this is what people like to do, right? They like to keep stuff secret to their stuff and go from there, right? So this is where most people like to keep run locally. Businesses want to do it except themselves. But right now, I'm going to show you on the slides. If I were to do this and say, okay, if I were to run this, what would be the thing? Right, guys, I only have like 2 minutes left, so I'm just going to go through this, and then I can answer questions after the class. So with quantization, you can run the model on laptop or PC. You can get fast results without paying cloud cost. You can use it offline, so you don't have to be connected to the internet, private secure. You could be on an airplane and ask questions to an LLM if you're running it locally, right? You don't have to worry about like a server going down because you're using this on your computer. What we talked about before is that quantization may not always perform well. They might lose accuracy, can sound a little bit less natural, and struggle with more reasoning issues, right? So you have to sort of do it. So I'm going to give you an example of saying, if I'm an enterprise and I want to run 3.170b, I'm not going to suggest an enterprise to run a quantized model. I'm like, if you want to keep security and you want to keep everything to yourself, that's great, but you don't want to lose performance on LLM. So you need to have information and total built, you need to have things built out, right? So I give an example below of how would it be if I were to load a Llama 3.170 deployment. So obviously you want top of the grade GPUs for this, right? So NVIDIA H100s. Two NVIDIA 100s is about 160 gigs of RAM. Remember we talked about the model weight? If you were just to buy 2 of those, that becomes 160 gigs. You're like, well, I should have enough, right? But you need to think about inference and overhead. So it's not enough just to host and load the model on your GPUs. You also need space on how to run inference. And inference, when I mean inference, is actually asking questions to the model. It needs space to process, needs space to look at it and be able to go run through the transformer and come out. So you need to have at least 180 to 225 of extra informations, of extra data, right? So you would need to have sort of 3 NVIDIA H100s. So when looking at that, we're able to have about 240 gigs, right, of leftover RAM. And then with that should be sufficient enough because that hits our total memory needed. So provides sufficient necessary headroom for stable inference. So like I said before, as a rule of thumb, if the model weighs this much, that's fine, but please leave at least in the 30-40% to run inference. And inference is what you need if people are going to ask questions. So to run locally, it's fine to have one person message. You don't need that much inference needed. But if you're running for this for the enterprise and everyone's going to be it's going to be asking questions to your locally hosted model, you need to have enough sufficient space and cost effectiveness in order to run this. And like I said before, for known production, most models are not quantized, but that's only made for POC work. So if you want to see if this is working well, you don't have to have all the starting costs up front. But once you start getting into production and you're using this across the enterprise and you want to use a local model that's stored, you need to think about these costs. So what's the cost of this, right? I think right now, NVIDIA's H100s with 80 gigs each were about 35 to 40,000 US each, right? So the estimated cost of having 3 of these would be about $105,000 cost. You need to have a good CPU that's able to process that. So AMD, EPYC, Intel, and Xeon, that's going to cost about $6,000 to have that good CPU. You need to have a good motherboard set in. You need to have sufficient memory, right? 512 gigs of RAM at least in order to support all the different processes that are happening. You need to have enough sufficient storage, 2 terabytes of storage coming in. You need to have a good power supply. As it's coming in, the cost of electricity, etc., is going to be separate costs on top of this, right? You need enterprise cooling to cool down the graphics cards, and you need cables, etc., network cards, etc. So you're looking at a total hardware investment about $118,000, or with taxes assembly, $130,000 at the end of it. Again, when you're running this on a local enterprise software, we're not thinking about running this on one person responding and using this. You're looking at hundreds and thousands of users inside your enterprise talking to your local enterprise LLM. You need to have enterprise sufficient hardware to be able to respond to all this to all the people coming in. And this is what it would take in cost, total upfront cost of actually having and loading a local hosted model with physical hardware on your premises. Now, that's just the local cost. Then we need to think about the maintenance cost on top of that. So if we were to do calculations of 30 days for 1 month of 12 cents kilowatt, and people are going and using this model, the monthly cost would be $260. The data center cost of rack space, cooling, networking, $1,000. You also need to think about hardware depreciation cost. As much as you invested that in today, in 3 months from now, it's going to be cost of depreciation. So that also needs to be looked at your total costing, and plus your monthly support and monthly maintenance support if something goes wrong, IT support looking at this. Again, your total monthly cost would be $5,371 on top of it. So again, these are the hidden costs that you need to think about when loading enterprise local machines. So doing this, having this type of hardware is going to be really fast. You can have about 5 to 10 users. Again, be careful with this one, 5 to 10 concurrent users. Response latency 1 to 2 seconds, precision in this. So if you want to have more concurrent users, you'll have to do some sort of load balancing, which is a separate cost. And you have to see how long, and if you want, and again, there's batch inference, etc. But again, this setup that we just did and all that costing is only for 5 to 10 concurrent users only. So again, these are the full implementation costs of running something locally. And again, people might say, well, why would I want to spend that much and do something that locally and put all the investment? Again, if you're a research firm with R&D and you're really careful and you're really worried about confidential information leaking, you don't want your competitors to have this. You don't want any information leaving it, but you want AI capabilities in your enterprise. This is what would it take to create an enterprise solution for your business. So I did a quick comparison between enterprise and cloud setup. The enterprise setup for the cost versus cloud setup this way. So you can see here that just looking at the maintenance cost is obviously 1/5 of just comparing API cost, right? So we know that enterprise API cost, again, you're not putting that full investment of hardware. You're not passing the monthly cost. You're not doing all this stuff. So obviously this is why people decide to go with cloud providers, because the cost of this is a lot more cost effective itself. The only time where you would say local is running cheaper, and again, I put the example here, is the 1 billion tokens a month. So if you're people going in there and you're using this LLM like crazy, then it may be cheaper to run these things locally because you're not have to pay those enterprise costs. But again, this could be overridden by throughput, right? If you use throughput, then your pay per token could be way less. So I'll pause here. We're over time by 7 minutes. As you can see here, we're getting deeper into the weeds. And the whole point of the AI for business is to arm you with knowledge of what does it take to actually run AI in business, and what would it take for you to run it locally versus API? What are the different ways that you can quantize it and run locally and save yourself some money, or to provide great latency from that metrics, right? And this is what I'm sort of running it through of when you're making decisions and you're proposing, hey, I want to create a chatbot. Okay, but where's the vector storage where is it gonna live? How much data does it have? What kind of API are you using? Which model are you using? And all those things and how it's going to be developed, all those things are part of that costing. So again, thank you so much for coming today. I know we went over from the cost perspective like that. Next week, I want to go deeper into the different areas of this. And what we'll be doing is setting you guys up in groups, because the last thing I want to talk about is sort of week 5 is coming up really fast. And the last part of the project is to sort of have a proposal sort of finished up. So let's pull this up to the last week's slides. Remember that we have a proposal the last week, and you're supposed to develop a strategic proposal of a hypothetical GenAI initiative that solves a business challenge that you're trying to learn in this course. What's the problem to include? A problem statement, proposed GenAI use case, build and buy justification, cost estimate, implementation plan, how you're going to mitigate risk, and the expected ROI. And all this information you can pull directly from the slides yourself, and you'll be sort of be put into groups of 5 to 6 individuals, and you'll be given 5 minutes to do a live pitch of what proposed plan are you doing and how you're going to justify this business idea. And we'll go from there. So again, this Wednesday, I may be setting up everyone in groups. I'll be sending that out and probably ask the team to sort of put the names in certain groups. And then that way, the following week, we can start getting some time in class and have the team start brainstorming of how they want to deliver that pitch and go from there. All right, thank you so much, everyone. I'll stay back on an extra 10 minutes if people have extra questions and try to answer them as best as I can. Thank you so much for joining me today.
Thanks, Luis.
Thanks, Luis.
I have a question, Luis.
Yes.
Other than the hosting cost, right? So if you were to host the LLM on your on-prem or on AWS server, right? So would that mean that you would have to kind of like keep training the models, or you would have the same kind of like problem whenever you download it, and that would be the snapshot of the data, and then just go from there?
That's a good question. So when you download a model, let's say Hugging Face 3.1, right? You're using this model and it's working great for you and it's fine from there. But Llama 4 just got released last week. So what does that mean? Before you go and you throw in production and you switch your whole hardware, what I would first do is analyze, run a test evaluation saying, okay, is Llama 4, the new model coming out, doing better than 3.1? Am I getting a lot more better responses? If you're seeing that your model is getting better responses with the new Llama 4, then you would have to remove the old model that you have in there and redeploy with the new Llama model that you have. And if it requires more space and requires more memory, you might have to upgrade your own memory to accommodate for this. Now, you can save a lot of this cost of running locally by using your own AWS bucket, right? And load models that you want on the cloud itself. But again, that defeats the purpose of why you're trying to do this, right? The whole purpose of trying to run your own models locally on your own hardwares is to make sure it doesn't go in the cloud and make sure all the information gets secured, right? So again, people might have their own reasoning of running their own local models that way, or they want to do the other things that way. But the most way I've seen is either through API, through SLAs to protect information, or they want to be super secretive and they want to roll out their own LLM models on their own enterprise locations that way. Okay, Sachin had a question. Can you help differentiate the roles of data scientist and analyst and ML architect, since we were running out of time? Maybe a separate message or look to. Yeah, so I know we run out of time, but I'll be talking that next week as well. I'll be going over the slides that we missed. So I'll be going over this slide itself, the dev team where we left off, AI development costs for each one, what they do, etc., and going deeper into that cost effectiveness that way as well. So don't worry, we're going to be talking about that. So we can go from there.
Yeah, Luis, the reason I asked this question is, when doing a proposal to the leadership team, saying that, hey, we want to form a team to do certain tasks, and we need so many people. We want to be clear of what are the roles and responsibilities and cost associated with each of these engineers, right? So
exactly. So I'll definitely talk about that. I'll show you the staffing allocations, annual salary estimates, a breakdown per cost per rollout, and what you need for a team all of that. So for sure.
Cool. Thank you.
I have a question, Louis. Are these models, when hosted on the cloud, I mean, multi-tenant or single tenant? I mean, if it's enterprise, I know it's a single tenant. They don't want to share because of the privacy or anything. But in general, when I want to go and play around, is it going to be multi-tenant? I think it should be multi-tenant, right? So when I'm trying to play around, there may be some private data I'm putting in there, little data. So would it be part of the training, or they use it, or how does that work?
For sure. So there's two types of APIs you can pull from the cloud, right? So one that's private, that's enterprise. Those are single tenants. Those aren't shared with anyone. But if you have, example, API with OpenAI, right? And you don't have any service level agreements with them saying that your account is not going to be shared, then that's a multi-level. Those are going to be multi-level tenants, because what they do is they use that data for their training. So they capture information. They're sharing that same they're sharing that same services with others individuals as well. And they tell you right in the privacy policy, whatever you're doing here is going to be used for training, right? And only way for you to not have it sent to training is, I remember I think it's OpenAI, they have a little bubble that says make this a temporary chat, right? But there's no guarantee they're not using that for training. So the only way you can have sort of single tenant private ways of cloud is through OpenAI's or Azure or AWS's service level agreements of their API things that they have. Those are on single tenant computations.
Oh, okay. So we need to be careful when we are using like these free AI models.
Oh yeah. So if something is free, you are the product. Remember that.
Yeah.
I remember I think it was, I don't know if it was Salesforce or Meta. Someone purchased the ChatGPT Enterprise, they purchased their own ChatGPT Pro version, and they start inputting code from their business into ChatGPT to help decode their model and fix bugs. What happened was someone else from another team asked the question how to solve a coding problem, and saw the proprietary code being sent out on ChatGPT, like being like outputted and generated. They're like, what? How does the model know this? So they went out and they did an investigation, and they were able to go back to the computer where they found that person copying and pasting code into a web browser, and they found that web browser was ChatGPT. And they found 4 or 5 different individuals who posted the code in there get fired right away. Because again, these models they're not secure, right? They're not enterprise. They're not meant for training. Like the closest thing that came, I think after that, the first thing that came out was Microsoft Copilot, when they called it Enterprise. You can use this ChatGPT window for any questions like that, but don't try to put any personal information on this and stuff like that, blah, 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 right? So you have to be very careful if it's not a private API that's stuff like that has that, right? So
Git Copilot in enterprises
be
should
very careful
private,
when you're using these
single tenant,
things.
right? The Git Copilot being used in the enterprises should be single tenant, right?
Correct. But if you're using GitHub Copilot, they do have the SLAs in place to make sure they're not using your codes and going from that. Yeah, I've partnered with GitHub Copilot. They're good partnerships with us as well. They have extremely good privacy security settings for that.
Thank you.
If not, no one would use it for work. So all right, there was a lot of information. This class, hopefully you were able to digest it. If there's a lot more questions, remember office hours are open Wednesdays. And we can have a deeper discussion going down deeper. I know, Nagesh, I owe you a conversation as well. So
Sounds good. Thank you.
okay, awesome. All right. And everyone.
Thank you, Louis. So great, insightful session. Appreciate it.
Okay. All right. Bye, everyone.
Bye.